In order to determine the value of the constant k so that the equation has equal roots, we really have to understand that whole completing the square concept. So when we complete the square, what's really happening? Well, if I distribute so that this looks a little bit clearer, x squared equals 6kx plus 2x minus 14k minus 21. And I bring everything over to the left-hand side. X squared minus 6kx minus 2x plus 14k plus 21 equals 0. And let me factor out the x. So I've got negative 6k minus 2 times x plus 14k plus 21 equals 0. Now, if this is a perfect square trinomial, then half of the coefficient of the linear term, negative 6k minus 2, half of that squared will equal 14k plus 21, right? So think of it this way. If I've got x squared minus 6x plus 9, half of 6 is 3, and 3 squared is 9, right? Half of 6 is 3, 3 squared is 9. So we're going to do the same thing here. Half of negative 6k minus 2, half of negative 6k minus 2 is negative 3k minus 1. Negative 3k minus 1 squared, negative 3k minus 1 squared has to equal 14k plus 21. So I'm going to multiply this out. I get 9k squared plus 6k plus 6k plus 1 equals 14k plus 21. Now I can subtract the 14k, subtract the 21, 9k squared minus 8k minus 20 equals 0. Let's try and factor this. I think I'm going to try and 3k and 3k. I don't know if that's going to work. Maybe a 4 and a 5. 4 and a 5. No. 10 and a 2. 10 and a 2. No. Let's try 9k. 9k and k. Now I'm going to try 10 and 2. 10 and 2. 10 and 18. That works. So 9k plus 10, k minus 2. Let's just make sure. That's 10k. That's negative 18k. That gives me negative 8k. So that means that k can equal negative 10 ninths, or k can equal 2. Negative 10 ninths or 2. And you can see I'm scrolling up because that's what we have for an answer. K equals negative 10 ninths or 2.